Before we dive into the topic, I would like to give a short introduction about myself. I'm nowadays the Alluxio core maintainer, and at the same time, I also lead the AI product in the Alluxio, this company. Actually, behind this open source project, we do have a commercial company there. So I also lead both the open source effort and also the commercial effort, and to make sure we can deliver to the customer and the users a very good user experience. And before joining Alluxio, I have already in this we call like distributed system area or more than 10 years. I clearly remember 10 years ago, the main topic people still talking about big data. No matter talk about Spark, Hadoop, and the Snowflake, people thought, wow, it's so fancy. And that's the reason I joined this area at that time. And after 2019, I started do a lot of research together with the production, with the industry, almost every of the big company you can imagine, to adopt this kind of cutting edge technology to the production, including the framework like PyTorch, TensorFlow data, and also a lot of ecosystem around it to provide the data access there. Yeah. Before we dive into today's topic about the autonomous driving, I really want to ask one question: how many people here is really a machine learning engineer, develop the model and landing their AI strategy inside the company, or how many people actually also doing the machine learning infrastructure? Because actually, many times when we go outside, given we are infrastructure guy, many people just don't understand what we are doing. Can you guys raise your hand if you really relate to this area? Well, it's already more than my expectation. Usually, last time I go to Seattle, there are almost 100 people there, and no one raising a hand say they are infrastructure engineer. So here, at least, I saw several do the machine learning area. Wow. And actually, we already cooperate with a lot of autonomous driving company for a while, since 2018, 2017. At that time, people still start prototyping their journey go to the autonomous driving. People still focus on how can I even put a LiDAR onto my car to get the sensor data back and collect the information. So actually, that's the reason today in the San Francisco city, I haven't been in this city for a long time because you never want to drive from South Bay to here, to be honest. It gave a lot of traffic, back traffic and here. But today I saw the Waymo actually even running there, and they also serve the passage there. Back to the 5 or 6 years ago, it's very hard to imagine because people still try to put their hardware on their autonomous car, and actually nothing is implemented there. And nowadays, people jump to what we define the stage 2 here. People already start to run a lot of car in production, or they are in very large scale of road testing there. So I put this image here, just make people aware of what's the change as a data platform. Because as a top layer, you can see people previous doing the hardware enhancement, put every sensor in a car, and nowadays people go to production. I want to emphasize what happened as the lower here, what's the impact to the data platform actually to support this kind of business goal. At the beginning, actually, we start with several or very hot startup 2018. People say I don't really care about big data. The only thing I want to do is I just buy a NAS solution. I bought a storage, and I also have tens or hundreds of the GPU or card that I can run almost everything I need on top of this kind of infrastructure. If you come with the big data area, we say if you see you are really large scale, you will say you have more than 10,000 of nodes in your production, then you see very large. But at that day, this is already extreme large scale for the autonomous driving company. Usually it's the data size still at the terabytes level, for a single car or two cars to do the road testing and get the data back and generate some small model based on the very small volume of the data. And at the second phase, actually, people realize, actually, okay, I already assemble my car with all the sensor, with everything I want to do. I have to develop some software to make it like a platform and to meet our goal. Meet a goal, which means like I really want to do some meaningful road testing there. Usually what we saw is people do more than 1 million of the kilometer of the road testing, but usually it's more than 100 million of the road km of the road testing. At that time, people already start to do some middle scale of the model training there with like hundreds of the GPU cars there. And at that time, people also realize, like, given I have so many, maybe tens of the road testing car running there, I need some data pipeline to guarantee I can continuously gather data back from the real working car. For example, if you see the Neuro car or Waymo car running there, I need some at least every day or every week, I have to gather all this data back to my AI platform and do the training, generate a better performance of the model, and deploy it back to the Tesla driving car. At that time, we saw people usually have tens of hundreds of the terabytes data for their whole training data set. But nowadays it's very different and also reflect our topic called ADAS. ADAS is, you can think about, if you have like hear about the definition of the autonomous driving, they have L1, L2, L3 till the L5. This category meaning for L2 and L2 plus. Almost every time you do the autopilot or this thing, we think it's L2 or ADAS, like or L2 plus. At this time, given this situation, a lot of car company already deployed this car in production, like Tesla, like Waymo. And also a lot of cars doing some very meaningful like road testing there, which means they already have more than like hundreds of cars running road testing and also have 100 million of road testing data, all directly from the production data. So when you go to this phase, actually we can call it really large scale of data, because actually the data, whole testing data is already hundreds of petabytes. If you think about many different internet companies, actually their scale is just one scale or two scale larger than this kind of data. But that data is from the whole world of the people. This data only from maybe hundreds of the or thousands of the cars. Actually, it's tremendous large from the scale. And at that time, you have to first of all, you have to deal training with this kind of large of data. At the same time, you also want to build very smooth data pipeline to talk with internal data platform in the data center and the external edge, the car, to make sure like you can improve and iterate your product very rapidly. Otherwise, you will like crash by your competitor. It will be a nightmare. Yeah. And back to our story, just to give some ideas what Alluxio doing. Alluxio never handles the GPU side. So what we focus more still at the data side, how we can move the data, how we can provide the enough or sufficient I/O performance to your GPU to make sure you can achieve your goal, as I mentioned, to resolve the challenge in the previous slides. So we saw actually these certain barriers to effect you to do very effective AM machine learning adoption. The first of all, what we say is like low performance. I will give more detailed architecture afterward, why people say low inefficient data I/O from the existing architecture. And secondly, it's really about the GPU scarcity, because you know, like in autonomous driving, actually it have several different like job, highly related, highly depend on the GPU training. One is the perception, and also when you generate high quality mapping, and when you do the PAC decision, actually all this kind of decision is the backend is model. We have the deep learning technology or whatever, or even multimodal model to support it. So actually, if that case happen, actually almost every company I talk with, it's very hard for them to find enough GPU in a single cloud or single data center. So they always have to get some GPU from the Azure, get some GPU from the Google Cloud, get some GPU from on-premise, and get some GPU from AWS. They want to get it wherever they want to find this kind of GPU. The last really about cost management. if you see this platform, you will see like only in 5 years, people rapidly only want to do the prototyping to go to production. That definitely a lot of gaps there. Because at the beginning, if you are like an infrastructure guy, I just want to make my internal customer working. So I assemble everything very easily together. But afterward, I saw, okay, I only build a pen, but you want to use this pen to draw like a big picture, like a masterpiece. That's almost impossible. So when people find that, actually, given the situation, they already build the infrastructure there, and this infrastructure is not suited for the extreme large data like processing, and the cost management become very important because you're easily to see for almost every of the autonomous driving company, for the infrastructure part, it can easily increase 10 times or even hundreds of times in 5 years. Okay, at last, we will give some idea how we resolve issue in the real case. But before that, I will give some heads up what is really Alluxio meaning and what is Alluxio. Yeah. We define Alluxio as a data platform, which means we highlight with two different features here. The first feature is called high performance data access, because actually as a caching layer, if your performance is bad, it's no meaning. You just don't want to use it. I add another layer, but the actual performance is lower. Why I add it? And second, really, it's reflect to why it actually related to people's pinpoint, because we saw it's a lot of data siloed in the autonomous driving and also other industry. So we gave one function called unified global view. What it means of the unified global view, as you see here, actually, we started this open source project like at 2012, actually at AmLab at Berkeley. So it's a sister project of the Apache Spark. And at that time, we are unified the view for the different ETL job or the OLAP or OTAP, this kind of engine. Until now, actually, we expand our footprint to the machine learning framework, so including PyTorch, TensorFlow Array, actually all them all. If you think about if you are a data scientist, you want to consume some data from S3, you have to write some code to say, like, I have to call this S3 API. For example, I get the header, get the bucket first to list all the objects I have in this directory and send back to the PyTorch job. And I get every object one by one, feed into our GPU node, then do the training. So, but think about it. This is just for the S3. What if like I have another data in the HDFS, I have another data in the AWS 3, so I have to do it again. So on the top layer, actually, we provide some interface like Fuse, HDFS, or S3 for your like application. So which means you never have to change your API from that to adoption in this kind of framework. And on the lower layer, actually, you can see you have a lot of data siloed. It's maybe you use some public data set from the Hugging Face. Maybe it's stored on the S3. Maybe it's stored in your own on-premise data center, HDFS, NAS, or NFS, all this kind of storage. We also provide a connection to all this kind of things. So which means no matter which storage you want to connect to the different application, you basically only want to write one patch of code and handle all of them. So which means you don't have any migration cost. If you reflect to the previous like slide, we said like a GPU scarcity. What we saw is like given you have a lot of application running across a different cloud vendor or with a different portal there, actually it's very easy to migrate your data platform almost anywhere. Use Alluxio plus the Kubernetes to manage the GPU. In our one user, actually, they can easily to launch any of the training cluster in any cloud in 10 minutes. Previous, like they have to launch the GPU cluster very quickly. It's under 30 minutes. But actually, when they want to migrate the data from the S3 to the GCS, it always takes them like half week or 1 week for a training set. So actually, after this kind of change, actually, they are easily to migrate almost everywhere to reduce the cost and get the GPU from any cloud vendor. And previous I mentioned like if you are catching a system, there's no performance then you definitely don't want to use it. So I will dive a little bit deeper into our architecture to illustrate why we are high performance. First of all, there's some performance number here. Give a very straightforward idea how we can do it. We can achieve millisecond latency, 2.5 gigabytes per second throughput plus tens of thousands ILPS. It's usually like under 100 thousands of ILPS per GPU nodes, which means when you scale with your GPU cluster, actually we can perform better. It's almost a linear under 1,000 of nodes. So which means like it can rarely help you to overcome the IO bottleneck there. Just give you some idea about the old solution. If you directly connect with object store or using like a NAS solution, actually many of them cannot achieve like a millisecond latency. Give the object store usually handle its full infinity of the scale out, and also for the cheap like storage. So the latency for them obviously very high, and also at the same time given hardware like limitation. Usually for the single region of the or single available zone of the cloud vendor cloud solution, the throughput is limitation for all the customer, maybe tens of the terabytes per second. So give to the area of the customer. If you are not big customer, you should usually start from gigabytes level. And if you are extreme large company, maybe they give like a terabytes level of the bandwidth. So, but that is definitely not sufficient for the AI machine learning training there. Okay. And another thing is like, because we are caching solution, actually we don't have single point of value. If it's any node actually down, GPU node down for a certain reason, actually we will just fall back. And also it's not will stop your job or it have very limited effect for you. That's the reason I say like Jackson told me like it's a stability issue of the HDMI. I just recall our system. It's very like ridiculous if you face the stability issue there. For example, this morning, certain website down for a while because when I went get up, I want to swipe on the Instagram. I found it totally down. It's like ridiculous, like important for almost every company. We don't want to make your job down, no matter for the offline job or online job. And the last most important thing is how we achieve the millisecond latency. Actually, we have one technology we already use more than 5 years is a consistent hash ring, like can to from the client side to find the server side like data access very easily on the millisecond. Here is some example. Actually, I don't prepare fancy demo today, but I want to give some very straightforward idea how we perform if you compare to the S3 Fuse, direct access the S3 to training the ResNet 50. It's kind of very standard benchmark for the computer vision. And as you can see here, if you direct access data in the S3, actually we run this thing for 3 epoch, given the GPU is too expensive. And actually, the GPU utilization you can see is under 20%. So what the time actually is spent? Actually, it's mainly spent as a data loader, which means they move the data from the S3 into the local disk, then move into the CPU memory. Actually, it's the majority of the time consumed there. So we see this kind of workload is our target, and it's mainly for the IO bottleneck. So after we add Alluxio into as a middle layer there, actually you can see here the GPU utilization comes very high. It's like 93%. And at the same time, the reason you can see why it's happening because data loader become not a bottleneck anymore. It's only 1%. Because like this kind of frame already do very smart things. They do the async loading the data from the storage to the CPU memory, also async to the GPU memory, and also do the GPU processing at the end. But I still see a lot of gap there. Actually, we meet this gap to make sure you don't face any bottlenecks there. It's kind of very simple solution, but have a very good benefit because actually every percent of GPU utilization means tens of dollars every second in many cases. And actually, previously I say like we're already very straightforward technology, but I also want to give some idea how we adopt this kind of solution in the user's environment. It's kind of like simplify the architecture from certain of our customer and the user case. As you can see here, people do a lot of like ETL job when they get the data from their car, from the edge to their data lake house or data house. And they do some pre-processing there. You can think about resizing, you can think about rotation or any of the pre-processing you do there. And they feed this kind of data into the object store. It can be the raw data, which means like the small file, purely small file. And sometimes they put this kind of data to the iceberg table, which make this like more organized to consume for the next consumer. Previously, they used a NAS solution there, but you will feel very weird if you're from big data like area. No one really use NAS in this area. People usually use object store or HDFS to store data because actually it's cheaper and the scale-wise is much better. But the reason this user have to choose NAS is because almost every object store HDFS provide very poor POSIX interface to the upper layer application. But almost every of the PyTorch or TensorFlow job is running on the POSIX interface. So they have to choose one NAS to do the translation. At the same time, they also prefer high performance NAS. But given the budget limit for this customer, actually they're using the SATA SSD NAS together with the hard drive disk NAS to provide a better scalability with a cheap price there. But quickly they find there are some pinpoint there. First of all, the cloud NAS actually cannot offer enough I/O throughput there. As we mentioned there are some hard requirement at the AI model training. Usually you have to have like millisecond of latency, gigabytes of the throughput they provide to a single node, and also more than tens of thousands of the IOPS you provide to a single node. But cloud NAS definitely cannot achieve this goal. Actually, when they do the POC, they find for the 1 node or 5 nodes or 10 nodes, it's still okay. But then when they expand to more than like 20 nodes or 100 of nodes, the NAS quickly become the bottleneck there. So actually make their GPU utilization actually is pretty low. It's only around 30% to 50%. So half of the GPU actually is wasted because of the I/O bottleneck. And secondly, it's very hard to predict. Because previously, if you put everything into the cloud storage, actually you still have a single data lake there, which means your manage data is still very easy. For example, you know which data you want to keep in your storage and what data you want to remove from this storage. And actually it will help you to do the cost management there. But because they introduce this component, is NAS, actually they have no mechanism can manage the NAS and object store at the same time. Because as you know, like many autonomous driving, actually they have raw data put in. You can see it's unstructured data or even sometimes semi-structured data in your data lake house. It's very hard to image how you can manage this. I know a lot of companies working on the called AI metadata or the AI management of all this data governance thing. But actually, to be honest, I don't see one very successful manage all this kind of data. So which called the data silo there, and they realize after certain like half year and 1 year, almost half of their data move from the object store to the NAS, which is not expected because when they do the model training, the active data is only around like 2% to 5% of the total data set. But nowadays, they have already more than 50% of data put into NAS, make their cost management become very hard. So how can they resolve this issue? Actually, they start from thinking about I have to use a caching solution there. Actually, at the first time, they are not thinking about us, to be honest. They are thinking I just need a caching mechanism to resolve this issue because as I can see here, I need better performance. I need better data management between the serving layer and the persistent layer of the storage. So how can I resolve this kind of issue? They say I need a cache. They even think about Redis at the beginning, but given Redis is purely running on the memory, but it's super expensive because their single training can take hundreds of terabytes of data fed into a training. It's not possible. So they come up with our solution. In the end of the day, actually, they reduce more than 30% time compared to consume the cloud object store directly or compared to consume the data from NAS, which means they bump up their GPU utilization from 30% to 50% to more than 90% for their critical training job. And at the same time, they also avoid the 50% of data copy there. So previously they write very complex job between the object store and NAS for each individual task, which means every time you want to run certain job, I initiate a job to copy the data from the object store to the NAS. And when I don't need it, I just delete from that side. But delete usually not happen because you don't know which part is still needed by the customer and your internal customer, and which part actually you can free it very easily. Okay. And the second case, actually, the only difference I saw there, actually, they use all-flash NAS to resolve the performance issue. As you can see here, but all-flash NAS also have another problem because actually most of all-flash NAS is based on the NVMe. Sometimes it's also based on the IDMA to provide better performance. It's very specialized hardware to provide performance, which makes the cost is extremely high. Sometimes we can saw for each storage unit, actually it can be 5 times or even 15 times expensive than the object store, especially when you put the code layer of the object store there. So which makes the cost of the single company can reach tens of $1 million per year to buy this kind of all-flash NAS from the different company. So given the situation nowadays, just think about if you use the ADAS, this kind of system, you have tens, thousands of cars already running in production. Every car can produce terabytes of the data every day. You can filter it out or not, but actually, if the raw data is at terabytes level, and if you want to put all this kind of data into all-flash NAS, it's impossible. And it's just too expensive. Not mean you cannot do it. It's just because too expensive. Then people start to put the data into object store and do the cache management there. And actually, after adopting a caching system, actually they reduce 70% of the cost compared to NAS. And at the same time, they also get rid of the file copy and the file management. It makes the data automatic there. We have very active open source community there. And if you are interested to talk with us, join us at Slack.